Okay, simple corrections, but had to look at what we had. The units just were not right here, and they still aren't. I haven't changed them up here. Let's see, let's just trace through where the units were incorrect. I wrote them down hastily at the end of class and was not at all careful. If I multiply kilograms per meter by meters, I get kilograms. 0.05 times 20 is 1, so that this first term here should not be 1 kilogram per meter. It should be 1 kilogram. Second term is okay, I think, because 0.05 kilograms per meter times x is 0.05 kilograms per meter times x. Then we have what? We substitute the 20 meters in here. We get 400 meters squared divided by 2 is 200 meters squared. 0.01 times 200 is 2 meters squared. Time with units then kilograms per meter squared. That's going to give us kilograms again. So that's 2 kilograms. Then you have the minus 0.01. And let's see, I had a tilde on this and I erased it, but it should still be there. X tilde being the variable of integration we haven't yet substituted, so that should be x tilde squared. Okay. We substituted 20 meters, we got our 2 kilograms. We substitute x for x hat, and we get x squared over 2. So we have we have 0.01 kilogram per meter squared times x squared over 2. Of course, this is our lower limit, so we're subtracting that. So that's now correct, and this was correct. I didn't mess that up. I just messed this and this up, actually. So that my 3 kilograms per meter over here, which is what I get if I added the 1 and the 2 kilogram per meter I wrote down there, should just be 3 kilograms. Okay, this and this give us 3 kilograms. And with that modification, now I believe our units work out. Okay, so we integrate this with respect to x. Our negative 10 newtons is going to become negative 10 newtons times x. We have a negative 0.05 kilogram per meter times x. That's going to give us negative 0.05 kilogram per meter times x squared over 2. We're going to have, okay, we have a multiplication. Again, units aren't working out. Moving ahead of myself. This is then times our 10 meters per second squared. Then we integrate this. We have an x squared. That's going to give us an x cubed over 3. So we're going to have negative 0.01 kilogram per meter squared times x cubed over 3, but that's over 2. That's going to give us x cubed over 6 times 10 meters per second squared. And then that's going to be minus 0.05 x squared over 2 here. It's going to be kilograms per meter times x squared over 2 times 10 meters per second squared. And then it's going to be plus, well, minus, because we're distributing the minus 0.01 kilogram per meter squared times x cubed over 6 times 10 meters per second squared. All of this, and I guess that's the only parentheses I have, evaluated between 1 meter and 19 meters. Now we see that, well, actually it's going to occur twice. I thought that was going to subtract off, but that occurs. And then we get what we get. Okay, the difference in x is going to be 18 meters, so we're going to have negative 180 joules from this term. x squared is going to change from 1 meter squared to 361 meters squared. That's going to be 360 meters squared. And we're going to have a negative on that. 0.05 times 360 is 18. So we're going to have minus 18 joules from this term. 360 times, yep, negative 18 joules. I'm doing this in my head because I don't want to take the time to write it out. I'm going to stop and finish writing it out. I think what I'm going to get, I don't know what 19 cubed is. It's pretty close to 7,000. But we're going to get something here. I can square 19, 361, so I know what that's going to do. Not sure what x cubed is going to be, so let me approximate this and then come back.